Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. Today we are going to start our unit number 3, Fluid Machinery. This chapter consists of 12 marks, different types of hydraulic turbine, nozzle, diffuser, Pelton turbine, Francis turbine, reciprocating and rotary pumps, centrifugal pump, submersible jet pumps, all types of fluid machineries that are used for transferring energy or for creating energy with the help of fluid will be studied in this chapter. This chapter consists of 12 marks. The learning objectives for today's session are: number 1, study of turbine. Basically, what do you mean by state turbine and different types of turbine will be studied in this today's session. Second, types of turbine. Different types of turbine will be also studied in today's session. Starting with first, hydraulic turbine. Hydraulic turbine consists of number of rows fitted to a rotating shaft. When water flows from certain height through a nozzle to turbine and it strikes the blade of the turbine with high velocity and makes the shaft rotate. While flowing through hydraulic turbine, the velocity and pressure of the water reduces. This results in the development of torque and rotation of turbine shaft. There are different forms of hydraulic turbine in use depending upon the requirement. For vary or every specific use, a particular type of hydraulic turbine provides the optimum output. Hydraulic turbine is used to create or used to generate the power with the help of moving water or flowing water. Hydraulic turbine has a device called nozzle. A nozzle is a device of uniformly varying cross-sectional area of duct through which the water flow through the turbine. It is fitted to the end of pipe or penstock in a Pelton wheel turbine. The purpose of nozzle is to accelerate fluid during the acceleration and or during this process in which velocity of fluid increases on expense of pressure energy. For high velocity jet, more nozzles are provided to flow large amount of water. That is, the nozzle is a device having a duct-like shape in which the pressure the flow velocity of the flow increases and decreasing the pressure energy. The fluid the fluid yield where high amount of velocity is necessary, large number of nozzle or number of nozzles are arranged to get the high velocity. After nozzle, the point is diffuser. The diffuser is a device which is used to slow down the fluid. That means velocity of the fluid is decreased with the help of diffuser increasing the pressure. In hydraulic turbine, the function of diffuser is to recover the pressure energy of water from kinetic energy on turbine runner outlet. For high specific speed turbine, the efficiency is depend on diffuser process. S. S is where almost 50% of available head is utilized. The amount of coefficient of pressure recovery can be significantly influenced by the shape of diffuser. The diffuser is device that slows down the fluid, that is, it reduces the velocity of fluid head, and it is an opposite of an nozzle. The nozzle is one in which the velocity of fluid is increased. It is having the bigger inlet and smaller outlet, whereas the diffuser is one which reduces the velocity having smaller inlet and bigger outlet. Next point is types of turbine. Turbines are classified into various categories. Following are the some categories that we are going to discuss below. First, based on the type of energy at the inlet to the turbine. Based on type of energy at inlet to the turbine are classified into two types. One, impulse turbine, and second, reaction turbine. The impulse turbine, the water jet is directly striking the blade, producing impulsive force. The pressure of the fluid does not change while flowing through the rotor of the turbine. In impulse turbine, pressure change occur only in the nozzle of the turbine. Example of an impulse turbine is Pelton wheel turbine. And reaction turbine are the water jet directly strike the blade of the turbine. The pressure of the fluid changes while it flows through the rotor of the turbine. The change in fluid velocity and reduction in pressure causes reaction on the turbine blade, hence it is named as reaction turbine. Its example is Francis and Kaplan turbine. The second type of turbine is based on the direction of flow path. It can be classified into three types: axial flow hydraulic turbine, or radial flow or tangential flow hydraulic turbine, radial flow hydraulic turbine, and mixed flow hydraulic turbine based on direction of flow of path. Axial flow or tangential flow hydraulic turbine, in this flow path of the fluid is mainly parallel to the axis of rotation. Kaplan turbines are mainly axial flow hydraulic turbine. Radial flow hydraulic turbine, in this flow of the path of the fluid flowing mainly in a plane perpendicular to the axis of rotation. That is, the flow of path is perpendicular to the axis of rotation. And mixed flow hydraulic turbine, in this the flow path of the fluid is in both axial and radial flow direction. Such type of hydraulic turbines are called as mixed flow hydraulic turbine. Francis turbine is an example of an mixed flow type. Next type of turbine are divided into two categories, that is based on head under which the turbine works and based on the specific speed of the turbine. Based on under head which the turbine work can be classified into three types, that is high head, medium head, and low head. The high head is when the turbine which is having high head, that is impulse turbine, that is example is Pelton turbine. Medium head or low head are the reaction turbine, its example is Francis turbine or Kaplan turbine. Based on the specific speed of turbine, again the turbines are classified into three types. First is low specific speed, second is medium specific speed, and third is high specific speed. High specific speed example is Kaplan turbine, and it is also a reaction turbine. Medium specific speed is also a example of reaction turbine, and the example is Francis wheel. Whereas low specific speed is an example of impulse turbine, and its example is Pelton wheel. We are going to study in detail the two types of turbine, the Pelton turbine or Pelton wheel and the Francis turbine, in the next session. So this is it for today's session. Thank you. In today's session we have started our third chapter, fluid machinery. We will be completing this chapter in 4 sessions, and this chapter consists of total 12 marks. In today's session we have completed what do you mean by turbine and types of turbine. Thank you.